Okay, for the third and last talk of this session, Talia is going to describe some work that she did with colleagues at University of Washington and University of California in San Diego.
So hi, I'm Talia. Today I'm going to talk about REPLica. This is a UW-UCSD collaboration. One of my co-authors, Alex, is in the front in the hat, so say hi to him. Not in the hat anymore. Okay. So usually when I get up here at CPP or ITP, I talk about things that are sort of warm and fuzzy and easy for this audience to understand. So things like proof automation for dependent type theory. But today I'm actually going to talk about something that's maybe a little bit scarier for this audience. So that is a user study. But I promise you are in the right room. This is actually a user study of proof engineers. So my co-author, Alex, and I, both of us write tools for proof engineers. So in order to make sure that these tools are really useful to proof engineers, we want to make sure that we really understand their development processes inside of an interactive theorem prover. So what we've done is a user study of 8 intermediate through expert proof engineers as they go about normal coq development for an entire month. We've collected this data, and then we've analyzed it to answer 2 questions. So our first question asked about the kinds of mistakes that users make in their proofs and how they fix them. And then the second question asked about the changes that users make to their programs and specifications, and whether those changes reveal patterns where better automation or better tools could help. And what we found, it won't shock anyone, but what it will do is confirm some common wisdom. So for example, we found that our users most often fix proofs by fixing other things. So here's an example from an expert user who started a proof of a theorem, got to an impossible state where they had to prove for all n equals 0, realized that the theorem was incorrect, backed up, and then changed it. We also found that there were often repetitive changes across many files, sometimes over the span of weeks, where better proof engineering tools could help. So here is another set of changes from an expert user, making similar changes over and over again to a number of related lemmas. So what we get from this really are 2 things. On one hand, we get ways to build better tools through takeaways for people developing proof engineering tools, benchmarks to measure the success of these improvements, and a large public data set. But then on the other hand, we also get ways to make these user studies easier through infrastructure that we've built and through the wisdom that we've gained in the process. So that's why I'd like to share this all with you today. And I'll start with the infrastructure. So the infrastructure that we've built makes it possible to collect data on these proof engineers so we can analyze it. And we hope it will be useful if you're doing a user study, both inside of coq, and that the ideas will be useful for other interactive theorem provers as well. So this part will be familiar if you've seen one of my talks before. I'm going to give you the name of the tool, and it's going to be an acronym. So the tool name is REPLica. This stands for REPL Instrumentation for Coq Analysis. This is actually an acronym within an acronym because we instrument something called the REPL, the read eval print loop. So basically, this is a simple loop that all interaction with coq passes through. Whether you compile a file, whether you open up some IDE and you step up and down and modify some proofs, every time you do any of this, whatever UI you're in, coq is going to read in something, evaluate it, and then print some response back to you, loop around, and wait again. This is also how some other proof assistants work, like Idris and Hull. Coq gave us the catchiest acronym. So this is implemented for coq, and this is what lets us observe proof development in a lot of detail, which is something that previous user studies have struggled with, user studies of proof engineering. So one user study noted they had to make this simplifying assumption that proofs proceeded in 3 neat phases. And I think most of us have seen this sort of cartoon version of proof development before. You write your program, you write your spec, then you write some kind of interactive proof, and that's it. Of course, that's not really how things work. In real life, at any point along this process, you might realize that your program is incorrect, or your specification is maybe not expressive enough to prove what you want, and you might go back and fix it. And this matters to us because the proof engineering tools that we develop can help the proof engineer at any point along this process. So when we're doing a user study, we want to make sure that we can see this entire process. And if you look at something like version control data or artifacts, you'll miss out on a lot of this. So by instrumenting the REPL, we're able to see this whole process, which gives us really precise data. For this example that I showed you at the beginning, we can not only see the user going back and changing the theorem, we can also see that this type checked, and that the whole thing took the user 58.28 seconds. That's the benefits of using this infrastructure. Now, there are a lot of details about how this works in the paper. Now, just briefly, though, essentially, REPLica is made up of two parts, a client and a server. So this client is a cock plugin. And whenever this cock plugin is installed, every time that the user makes a change and the UI sends something to cock via the REPL, cock will just forward that on to the plugin, to the REPLica client. And this works using these hooks that we've built into cock 8.10 with the help of the cock developers, especially Emilio. And that lets plugin actually listen in on information from the REPL. So then, once the client gets a bunch of these, it will send them off in small batches to the server so that we can later reconstruct it for analysis. This infrastructure is UI independent because, it goes through the REPL, so we don't have to change proof general or cock IDE or anything like that. But it's also reusable. This REPLica tool is on GitHub, and you can use it. And also, these tools, this hook, these are in cock 8.10, just the normal release. So you can, use those if you'd like to. And we hope the ideas will also help, in other proof assistants. Once we built this REPLica tool, we then actually ran our user study. So this user study was of 8 proof engineers over the course of a month. Just a quick snapshot of our proof engineers. They were all intermediate through expert with at least 2 years of experience. Used cock for a mix of math and verification, some daily, some weekly, some monthly. Most of them used proof general, but one of them actually used a custom IDE. And most of them were on cock 8.10, but we did backport the hooks to special branches of 8.8 and 8.9 to support a couple of users. So we had these users install this REPLica plugin and then go about normal proof development for an entire month. So that every time they compiled a file or modified something inside of an IDE, it would start a new session and record the data. So this graph just shows what we call the interactive sessions, so ruling out compilation data broken down by user. As you can see, some users sent more data than others. So this is something, it's not really surprising, but it's something that we do take into account, when we do our analysis. To do this analysis, we took all this data and we reconstructed it into formats suitable for analysis. So on the left here, you can see a proof tree where a user attempted a proof, tried a tactic which did not succeed, and then backed up and then ran intros before trying the tactic again, and then succeeded. And on the right, you can see a sequence of reconstructed Git commits from the data. So all of this is public. The data set is all on GitHub, and you can see there the analyses and these proof trees and Git commits. Once we had all of this, we looked at it to answer our 2 questions. Now, there's a lot about this in the paper. I'm just going to give you some of our takeaways from this. So our first question looked at mistakes in proofs and fixes to those mistakes. So again, the first thing we found here was that our users, most often fix their proofs by fixing other things. So I showed you one example where a user fixed a specification. This could have been a specification, a program, an LTAC tactic definition. Essentially, we found that 75% of the time, rather than just tweaking a single tactic inside of a proof that was incorrect, users would back up and change something else entirely. And we did look, and this was distributed across all of our users in a pretty representative way. So this is evidence of the fact that this really is an iterative process. And this gives us some takeaways for proof engineering tools. So one of them is, if you're building something like a machine learning tool where you can predict tactics, for the user inside of proofs, it might be useful to think not only about tactic prediction, but maybe combine with some kind of tool that can repair a program or specification or even an LTAC tactic definition, to actually help proof engineers with that process too. So for our second question, we looked at changes to programs and specifications and the patterns they reveal. We didn't find any single change that was dominant across all of our users, but we did find repetitive changes for each user. And these changes did reveal patterns where better proof engineering tools could help. So we found 4 patterns. I'll talk about one of them, which is incremental development of inductive types. Essentially, for 3 of our users, we found this pattern of extending inductive types, and then also extending definitions and other inductive types that depended on them. So here's an example from an intermediate user. So this user added a whole bunch of constructors to this term type and moved this int constructor down. And the user then made the exact corresponding change inside of this identity fix point. And actually, this is just a really small snapshot of a much larger change that spanned 5 sessions, 3 weeks, and 63 changes, all related to this change in term. So this is the first of 11 benchmarks that we have in the paper for the improvement of proof engineering tools. Because we really think that proof engineers could benefit from current tools to help them update their proofs and definitions after they extend inductive types. Now, there is some existing work on this from a while ago, which I cite and talk about in the paper, but there's nothing really for a current version of COC. So we want to see something new here. So that's a snapshot of the user study. But in the interest of making this a little bit more common, I want to spend the remaining time talking about the wisdom that we've gained in the process of doing this. And that wisdom will take the form of 3 wishes, the fulfillment of which would have really helped us, things we wish were true to make this user study easier. So there's a lot in the paper about each of these and about how to grant them, but I'll again give a snapshot of each of these. So our first wish is for better abstraction of user environments. Now, we did pretty well with this. Our infrastructure was UI independent, and we were able to support multiple versions of COC. But unfortunately, when it came to the actual analysis, we found that we lost that abstraction. In particular, different UIs and different versions of COC all had different ways of interacting with the REPL, and our analysis had to take all of those into account. So we think this is one place where the ITP designer can really help grant this wish. In particular, by really carefully considering the trade-offs between customization of the ITP and abstraction of the user environment. So there are a lot of ways to customize COC right now. Here are all of the flags that you can run the command line REPL with. And here are just 3 of the ways that a UI can signal to COC's REPL that a user has backtracked. So I think right now we're leaning a lot towards customization, and maybe not enough towards abstraction. I think in theory, the REPL strives for this, strives for some abstraction, but I don't think it gets us quite there. So I would really like to see, especially some kind of conversation between the COC community and the Isabelle community here, because Isabelle has a very different, or they moved away from the REPL to a different interaction model, and I'm curious if this, solves some of the problems with user abstraction. So that's my first wish. So the second wish is for more information about user interaction. This is, again, a place where we did pretty well. We did get a lot of information, thanks to these hooks. But we found there was one problem here, which is that these hooks, they listened in on information that the UI sent to COC, but they didn't actually give us the response back from COC to the UI. So what this means is that in order to figure out if something succeeded or failed, we actually exploited IDE-specific heuristics. So we took advantage of the fact that my first wish isn't true. So we were able to do it, but this could be a lot better. So if you're designing an ITP and you want to make it easier to do user studies, I think these hooks are really a great place to start. Whatever interaction model you have, some kind of similar concept. But make sure that you're also sending the response information when you do this. So then our final wish is for more users. So we tried really hard to get a lot of users. I probably have emailed most of you. We also emailed top PL groups. We even made this promotional video, which was a lot of fun. But in the end, we only got 8 COC users, which were all intermediate through expert. And part of this may have been due to the demographics of the community. But part of it was also due, we think, to some deterrence in our screening process. So for example, we required fluency in English so that people could understand our materials. And we required at least a year of experience using COC. And in addition, the incentives that we appealed to inside of this promotional video and our other materials were mostly improving proof engineering tools, which may have attracted a small and advanced audience. So the study designer can do a lot to grant this wish, we think. First of all, by loosening these deterrents, maybe distributing promotional videos in many different languages, or not requiring as much experience. But also by considering the incentives that appeal to proof engineers. So I don't know if money is the right one. I mean, everyone likes money, but I think we should be talking a little bit about how we can, how we can appeal to proof engineers. What is the right incentive? Yeah, so then I think, the ITP designer will naturally also help grant this wish just by continuing to, improve the ITP and the infrastructure around it. Because, this will draw more users, which will, give us more people for a user study, which will in turn, help us improve the ITP and the infrastructure some more. So this will be a beautiful feedback loop. So hopefully I've shown you, how to make these user studies a little bit more common. And yeah, there's a lot more in the paper. I'd love to talk about any of this, and I can take questions.
Thanks for a great and inspiring talk. What can you offer the user of systems that have a different interaction model, like, let's say, AGDA? So a hole filling in model of interaction. What kind of what kind of hooks do you need into that to do reasonable analysis on that? And what are the phenomena that are in common and what are different?
That's interesting. So I don't actually know that much about how AGDA's interaction model works. I know, yeah, I mean, I think I'd have to learn more about the implementation, because for COC we ended up having to actually, look at the implementation to figure out where we could add this sort of hook. Yeah.
It seemed like you were saying that for each of the users you recruited, you had them go about their normal lives after they signed up. And yet you showed us an example of an expert user proving one of the first exercises from Software Foundations. How did that come about?
Yeah, that's a good question. Yeah. Yeah. I don't know. I mean, it's possible they were showing someone something when they were doing it. This is one problem, I think, with this. So like we're able to, collect a lot of data, and this is useful. But there's no way for right now for the user to like tag any information as like, I'm just going to do a fun exercise right now, or my friend is using my computer, or anything like that. So it's possible that like some of the data is polluted that way. But we did find a lot of examples like that. Even for experts. Yeah.
Okay. Yeah. Thank you for giving this very good talk. And I would like to ask, how do you think the AI methods will change the world of COC, and how soon it will happen?
I feel like Alex is. Can you? Do you not want to answer that? You don't need to answer that. Okay. Okay. Well, yes. I mean, a lot of people are working on. I think in particular on machine learning tools for proofs, and Alex is working on one of them, the ProverBot 9001. Yeah, I mean, I think it's a promising area. I feel like just from some of the examples we saw here and in general, I'd like to see more techniques like really make use of the type information, which I think Alex's work is looking at a little bit too, because I think the user certainly has this interplay with the specification as they're doing their proofs. Yeah.
You mentioned that people should look more at the interaction between Coq and Isabel. Have you looked at the PERL ITP project that included both people from developing ITP user interfaces for Coq and Isabel?
I haven't.
This was by Macarius and Enrico and some other people.
Oh, okay. Yeah, I mean, I haven't looked at it, but I would love to take a look. I think just in general, I want to see more in this case, more conversations between the communities, because the ITPs have different implementations, and I don't know, Coq at some point was talking about having a more, making it possible to customize the IDE to different logics, and it's like, well, if you're doing that, I feel like you want to talk to the Isabel community. And yeah, the interaction model is another place where this comes up. So when we're at these conferences, I want to see more mingling.
I don't know. So I had a quick question here. So with a slowly, but in fact positively increasing number of industrial users of these systems, additionally also with the growth that we're seeing right now in human-computer interaction and HCI, particularly, for instance, at the University of Washington, do you see there as being opportunities out of these studies for some company who, I don't know, has billion-dollar ambitions, perhaps, to really try to squeeze productivity and efficiency out of these kinds of systems? Have you heard from any of those kinds of audiences?
That's interesting. So we're using this on a very small scale at Galois right now. So I'm working with a proof engineer on improving one of my tools, and basically so that I don't have to always be in Portland, but if I want to go replay something and figure out what he was doing with my tool and how I can improve it, I'm having him locally log everything with the tool. And then he's actually using the proof engineering tools, which is fun. I know some of the existing user studies of proof engineers were at Trustworthy Systems, I believe. I think most of the work. So I'm talking to them too, just about the infrastructure involved and if it could help them. Yeah, I think I'll be in Australia in May or something.
Okay, I think we'll have to stop here. Poor Talia has been drowning under questions. Okay, let's thank her again.